Number 4, state whether each example describes effusion or diffusion. If you guys remember from the notes from the PowerPoint presentation, I made one clear distinction between effusion and diffusion, and it was the presence of a small opening. So A, as a puncture occurs, air moves out of a bicycle tire, right? As a puncture. Now, unless you have a lot of, random, Magnum 45s, hanging around your bicycle, it's probably going to be like a puncture vine, a sticker, or maybe even a nail. It's going to be a small puncture, a small opening, right? So that presence of a small opening makes it effusion. Moving on to D, when ammonia is spilled on the floor, the house begins to smell like ammonia. Again, we're spilling this onto the floor. There's no small opening above the floor that lets this gas out. It's a completely wide open area. It's a wide open area. There is no small opening. That makes it diffusion. C, and if you got the wrong answer on C, I think I can understand, but I'll try to give you a sense of scale here. The smell of car exhaust pervades an emission testing station. Now, if you thought, that exhaust is coming out of a tailpipe, and a tailpipe is a small opening. Okay, I see you understand the definition of effusion, and you're trying to remember this added point of a small opening. That's awesome. That's great. But that exhaust opening is pretty darn large compared to the size of the actual gas particles. So we're not going to consider that a small opening. The second thing is I want you to continue to read the prompt. Car exhaust smell pervades an emission testing station, right? This is a large area. So again, a car exhaust tailpipe, exhaust pipe, not considered a small opening. It's much too large because we are talking about gas particles that are very, very, very tiny. So for C, we'll go with diffusion.